Let's read the question. Figure 7.1 shows a coil of wire wound on a thin plastic cylinder. The plastic has no effect on any magnetic field. The galvanometer is extremely sensitive. First of all, the galvanometer is the instrument or a device can calculate or can find the current. It is the device to detect the current and it shows the value. It is extremely sensitive, which means even it can detect a smaller amount of current. Unlike ammeter, the function of ammeter and galvanometer is the same. They detect the value of current, the magnitude of current, and it is more sensitive than ammeter. The galvanometer is more sensitive than ammeter. A magnet is fixed to a small trolley that runs without friction on a track through the cylinder and coil. So here is a cylinder. Around the cylinder a wire is wound around and it is connected to the galvanometer, and here is a small trolley where the magnet is placed over on it, and it is moving on a frictionless surface, and it is moving through the plastic cylinder. As it is moving through the plastic cylinder, magnetic field lines from north to south, magnetic field lines are being cut by the coil, induces current. So this current can be detected. The trolley is released from a point A, so it runs through the coil from right to left, from right to left. State and explain what is observed on the galvanometer. What is observed? First we have to state what is being observed. We observe a deflection on the galvanometer. And what is the second point? Explain this. How will you explain? Explain what is observed on the galvanometer, how there is a deflection. The explanation is, as the trolley reaches this point 1, suppose the galvanometer shows the deflection to the right, momentary deflection. It deflects to the right and get back to the original position 0, the mean position, equilibrium position. It goes to the right for the momentary deflection it shows. As the trolley reaches the other edge, and the second point here, the trolley is moving out of the cylinder, you can see opposite deflection. It goes to the left for a moment and come back, get back its position. So that's what you are explaining here. So you can explain reverse, the deflections are reversed, or reversed, or you can explain why there is a deflection. You can say rate of change of magnetic field lines. Second question, the trolley is now released from a point B, so it runs through the coil from right to left again. In this case, here is the point B, here is a trolley, and here is a magnet, and is being released from this position. So you would know when it reaches the position 1, the speed is now greater than when it was at the position A. So speed increases. What will happen? It will show the larger deflection. Before, if it was 1 ampere, now it will show 2 ampere. Example, I give some value for an example. So what you observe here, state what is observed on the galvanometer. Our observation is larger deflection. Larger deflection. And the next question, explain why it is different to your answer in A1. Now you will be saying here higher speed. Speed of trolley is higher, or you can say rate of change in magnetic field lines. Rate of change of magnetic field lines is higher. The higher rate in change in magnetic field lines when it is traveling from the point 1 and 2, 1 to 2.